Swayam Prabha. Digital India. Educated India.
Now I will define this class of problems NP. This is also going to be class of all decision problems. But I will write this informally again. Okay, so this is lots of some not so clear terms here. So, verified certificate. So, these are problems. Okay, so first of all, NP does not stand for not polynomial time. Okay, we do not know that yet. So, what does NP stand for? Non-deterministic polynomial time. So, if you are seen an automata course, you would have seen non-deterministic finite automata, non-deterministic push down automata, non-deterministic Turing machines. It is related to that non-deterministic Turing machine. So, if you want a formal definition, it is a set of problems for which there is a non-deterministic polynomial time algorithm that will solve the problem. Okay. To translate it in the language we are used to, it is a set of all decision problems. Decision problem means the answer is always yes or no, for which the S, if somebody has to verify the S answer, there is a way to verify it in polynomial time if given a certificate, given a proof of the S answer, one can verify in polynomial time. Okay, let us see some examples. So, this is not a again, if you have used non-determinism Turing machines, then it is very easy, because there is a guess, there is some path in the Turing machine which will lead to an accepting state given if the answer is yes. Okay. So, that path is actually the certificate. But let us see some examples and you will get the idea. So, suppose let us first of all let us make this clear. P, the whole class, is contained in NP. Why is this? That I do not even need a certificate. If the problem is solvable in polynomial time, that algorithm itself is a certificate. So, I run that algorithm and I get the answer, and that is my verification. So, there is no, I do not need an extra certificate. So, if a problem is solvable in polynomial time, it also belongs to this class NP. So, NP is a bigger class, we think, and I will explain why I say we think. Okay. So, let us look at an example. So, suppose I give you a 100-digit number and I want you to check whether it is composite. Okay. 100-digit number, I want you to check, tell me, convince me that it is a composite number. Okay. How will you convince me that this number, 100-digit number, you spent 3 years trying to check that? I am not worried about how much time you checked, and you found out that answer is yes. Can you give me a certificate which I can verify easily? That is it. You just say 2483 divides this number. 2483 is a divisor of this 100-digit number. Okay. I do not know how you found out, you spent a lot of time, because that is, we are not talking about P, right. The time to solve that may take a long time, we do not know that, but you can give me a certificate which is a divisor, which I with my limited time can verify. What is my verification algorithm? I will divide, which I can do, right. So, I take your number and you tell me this is a divisor, I will divide it and verify that So, compositeness is the number composite is actually in the class NP. Okay. Let us give another example. So, I give you a graph and I want to check whether it is Hamiltonian. Does it have a Hamiltonian cycle? Right? What would be the certificate you will give me to convince me? Right? This is a very complex 100,000 vertex graph. Right? I give you and say, okay, is this Hamiltonian? I don't, because I told you last time that we don't have an efficient algorithm to test that. So, you can't run an efficient algorithm and find out and tell me that, right? Then that algorithm would be a certificate for both of us. We don't have an algorithm, but how will you convince me that yes, this graph has a Hamiltonian cycle? So, you just give me a Hamiltonian cycle. What is a Hamiltonian cycle? You give me a permutation of the vertex set and you say, here is a cycle, go from 1 to 7083 to 42 to 11 to 81 and so on and so forth. And what is my verification algorithm? I will just go to my adjacency matrix and see that every adjacent thing which you have mentioned is actually an edge and that it covers all the vertices. Right. So, here that is a decision problem. Is the graph Hamiltonian? Is the decision problem for which the S answer can be verified in polynomial time with the polynomial size certificate. Right. So, let us write this. So, compositeness is the problem of whether it is in composite, Hamiltonicity so I mentioned about this prime, is the number prime. It was a long standing open problem to come up with a polynomial time algorithm for this.